my dear students. We are now in our lesson for week 2 in quarter 1. I am Teacher Eleanor, again your teacher in General Mathematics. If you are now ready, then let's begin. Now, bring out your worksheet. Be sure that you're in a comfortable learning area. Prepare your notebook where you can write down your notes about our topic. Since our subject is math, be sure to have your answer sheet. Rational functions can model a number of real-life situations. One particular example is the help that is extended by the government to the citizen during the time of pandemic. Majority of our fellow citizens experienced hardship and required help coming from the government. As a response, they provided a particular amount to a certain percentage of the population that can be represented as rational function. To determine how much either in cash or in kind an individual may receive. Real-life situations that involve rational functions is mostly seen in economics and science. However, other disciplines also incorporate this concept. In this week, learning competencies are represents real-life situations using rational functions, distinguishes rational function, rational equation, and rational inequality, solves rational inequality, and finds the domain and range of a rational function.
First, let us define a rational function. A rational function, r of x, is a function of the form r of x is equal to p of x over q of x, where p of x and q of x are polynomial functions and q of x is not equal to 0. The domain of r of x is a set of real numbers such that q of x is not 0. The following are examples of rational functions. R of x is equal to x raised to the 4th power minus 1 over x plus 1, where x should not be equal to negative 1. Both numerator and denominator are polynomial functions. The denominator has restriction because it should not be equal to 0. Number 2. F of x is equal to 1 over x, where x should not be equal to 0. The numerator 1 is a polynomial function with a degree 0. The denominator is a polynomial function and it must not be equal to 0. There are different real-world relationships that can be modeled by rational functions. Let us take the following examples. A car is to travel a distance of 50 kilometers. Express the velocity v as a function of travel time t in hours. Let us first show the relationship using a table. Remember that as time increases in traveling, the velocity or the speed of a car will decrease. So we have the table, time in hours and velocity in kilometers per hour. So if the time is 1 hour, then the velocity is 50 kilometers per hour. If the time is 2 hours, the velocity is 25 kilometers per hour. If the time is 3 hours, the velocity is 16.67 or 16.67 kilometers per hour. If the time is 5 hours, the velocity is 10 kilometers per hour. If the time is 10 hours, the velocity is 5 kilometers per hour. Thus, the function v of t is equal to 50 over t can represent v as a function of t. We have our second example. President Duterte allotted a budget of 60,000 pesos for the senior citizens in each barangay. The amount will be divided equally to all the senior citizens in the barangay. Write an equation showing the relationship of the allotted amount per senior citizen represented by f of x versus the total number of senior citizens represented by x. Showing the relationship in tabular form, we will arrive at this table. So we have the number of senior citizens, X, and the amount allocated per senior citizen. So if we have 10 senior citizens, the amount allocated per senior citizen is 6,000 pesos. If we have 20 senior citizens, we have 3,000 pesos. If we have 50 senior citizens, we have 1,200 pesos. And if we have 100 number of senior citizens, then the amount allocated per senior citizen is 600 pesos. Notice that as the number of senior citizens increase, the amount allocated per senior citizen decrease. In writing a representation, we will arrive at f of x is equal to 60,000 over x. Suppose a sponsor wants to increase the budget allotted for each senior citizen by donating additional 350 pesos per adult. If K of X represents the new amount allotted per senior citizen, construct a function representing the relationship. Using the table we used earlier, so we have number of senior citizens as 10, then the amount allocated per senior citizen now will be 6,000 pesos plus 350 pesos. If we have 20 senior citizens, the amount allotted will be 3,000 pesos plus 350 pesos. Then if we have 50 senior citizens, we have 1,200 pesos plus 350 pesos. Then if we have 100 senior citizens, then we have the amount as 600 pesos plus 350 pesos. Thus, the representation of the rational function is K of X is equal to 60,000 over X plus 350. Now, we will compare rational expressions using equality and inequality symbols. Thus, we will further classify the differences among rational equation, rational inequality, and rational function. To determine the difference among rational function, rational equation, and rational inequality, study the table below. We have rational equation is an equation involving rational expressions. Example of a rational equation is 3 over x plus 5 over 2x is equal to 2 over 3 or 2/3. This is also called as fractional equation. Then number 2, rational inequality. It is an equality involving rational expressions. Example of rational inequality is 3 over x minus 2 is greater than 5 over x. Then we have rational function. It is a function of the form f of x is equal to p of x over q of x, where p of x and q of x are polynomial functions and q of x is not a zero function. Example for this is f of x is equal to x squared plus 3x plus 2 over x plus 2. We have additional examples. Determine whether the given sentence is a rational equation, a rational function, a rational inequality, or none of this. Number 1, x minus 2 over x plus 3 is equal to y. So this is an example of rational functions because the symbol y is also a representation of a function of x or f of x. Number 2, square root of 3 over x plus 3 is less than or equal to 3. None of this because square root of 3 over x plus 1 is not a rational expression. In solving a rational inequality, let us study the given examples. First, let us define a rational inequality again. A rational inequality is an inequality involving rational expressions combined with greater than or equal to, less than or equal to, less than, and greater than. To solve a rational inequality, number 1, write the inequality with a single rational expression on the left-hand side of the inequality and 0 on the right-hand side of the inequality. Number 2, determine over what intervals the rational expression takes on positive and negative values. The first step in number 2 is you locate the x values for which the rational expression is 0 or undefined. Factoring the numerator and denominator is a useful strategy. Next step, mark the numbers found in the first step on a number line. Use a shaded circle to indicate that the value is included in the solution set, and a hollow circle to indicate that the value is excluded. These numbers partition the number line into intervals. Third, select a test point within the interior of each interval in the second step. If they make the inequality true or false, if true, then they are part of the solution. If false, then they are not part of the solution. And then the fourth one, summarize the intervals containing the solutions. Let us have examples of solving rational inequalities. Example number 1. Solve the inequality 5x over x minus 1 is less than 4. We have to rewrite the equation with 0 on one side. So we have 5x over x minus 1 minus 4 is less than 0. Then we have to simplify the left side. And the LCD is x minus 1. X minus 1 divided by x minus 1 is 1 times 5x is 5x. X minus 1 divided by 1 is x minus 1 times negative 4 is less than 0. Then, 5x minus 4 times x is negative 4x. Negative 4 times negative 1 is positive 4 over x minus 1 is less than 0. We combine similar terms. 5x minus 4x is x. Then you just copy positive 4 over x minus 1 is less than 0. Then we have to find the values of x that will make the rational expression 0 and undefined. So to get the value of x that will make the rational expression 0 is we have to use the numerator. So we equate the numerator to 0. So if x plus 4 is equal to 0, then the value of x that will make the rational expression 0 is negative 4. Then we have also to find the value of x that will make the rational expression undefined. So to do this, we have to use the denominator. We equate the denominator to 0. So if x minus 1 is equal to 0, then x is equal to 1. The rational expression will be 0 for x is equal to negative 4 and undefined for x is equal to 1. Now let us plot the points on a number line, and we will use hollow circles for negative 4 and 1 since these values are not part of the solution set. Because if we substitute negative 4 and negative 1 in the given inequality, they do not satisfy the given inequality. Then next is we have to construct the table of values. So we have the first interval is x is less than negative 4. Then the second interval is x is greater than negative 4 but less than 1. And then the third interval is x is greater than 1. Let us now determine which portion of the given inequality or the given number line will satisfy the given inequality. So let us test points from these intervals. So if x is less than negative 4, so let us use negative 5 as the value of our x. We substitute negative 5 in the given inequality. So we have 5 times negative 5 over negative 5 minus 1 minus 4 is less than 0. Then 5 times negative 5 is negative 25. Negative 5 minus 1 is negative 6. Minus 4 is less than 0. Then we simplify the left side. The LCD is negative 6. Or it can be positive 6 because if you simplify negative 25 over negative 6, it is changed to or it is simplified as positive 25 over 6. So let us use 6 as the LCD. Then next, 6 divided by 6 is 1 times 25 is 25. 6 divided by 1 is 6 times negative 4 is negative 24 is less than 0. Then 25 minus 24 is 1 over 6 is less than 0. So the statement is a false statement, therefore it is not a solution. Or the numbers which are less than negative 4 are not solutions of the given inequality. Then next, we have the second interval. So let us use 0 as the number which is greater than negative 4 but less than 1. So we substitute again 0 in the given inequality. 5 times 0 over 0 minus 1 minus 4 is less than 0. 5 times 0 is 0. 0 minus 1 is negative 1. Then minus 4 is less than 0. 0 divided by negative 1 is 0. 0 minus 4 is negative 4 less than 0. So, negative 4 is less than 0, so the result is a true statement. Therefore, the numbers which are greater than negative 4 but less than 1 are solutions of the given inequality. Then next, we have the third interval. So, x is greater than 1. So, let us use 2 as the value of our x. We substitute 2 in the given inequality. So 5 times 2 over 2 minus 1 minus 4 is less than 0. 5 times 2 is 10 over 2 minus 1 is 1 minus 4 is less than 0. 10 divided by 1 is 10 minus 4 is less than 0. 10 minus 4 is 6, so it is less than 0. Okay, is 6 less than 0? Okay, no, it is greater than 0. Therefore, this is a false statement. So we can say now that the numbers which are greater than 1 are not solutions of the given inequality. So the solution set now is given by the set which is x is an element of a real number where x is greater than negative 4 but less than 1. The graph is shown below. So the solutions of the given inequality are the numbers which are greater than negative 4 but less than 1. Let us have our example number 2. Let us solve x plus 2 over x minus 3 is less than or equal to 0. We set both the numerator and the denominator equal to 0, then solve. Test the meaningful numbers. So we have the numerator, we equate it to 0. So if x plus 2 is 0, then x is equal to negative 2. Let us substitute negative 2 in the given inequality. So we have negative 2 plus 2 over negative 2 minus 3. Negative 2 plus 2 is 0. Negative 2 minus 3 is negative 5. 0 divided by negative 5 is 0. So the left side is equal to the right side. Therefore, it is a true statement. Therefore, negative 2 is a solution of the given inequality. Then we have to equate also the denominator x minus 3. So if x minus 3 is 0, then x is equal to 3. Then we substitute 3 in the given. So we have 3 plus 2 over 3 minus 3 is equal to 3 plus 2 is 5. 3 minus 3 is 0. So the result is undefined. If it is undefined, it is a false statement. Thus, 3 is not a solution of the given inequality. We separate the number line into intervals using the numbers found. So we use a shaded circle at negative 2 because negative 2 is a solution of the given inequality. And then we use a hollow circle or an empty circle at 3 because 3 is not a solution of the given inequality. Then we have to construct the table of values. So we have the first interval as x is less than negative 2. Second interval, x is greater than or equal to negative 2 but less than 3. And then we have the third as x is greater than 3. Then we have in the first column, we use negative 5 as the value of our x. So we substitute negative 5 plus 2 over negative 5 minus 3 is less than or equal to 0. Then negative 5 plus 2 is negative 3. Negative 5 minus 3 is negative 8 is less than or equal to 0. Negative 3 divided by negative 8 is positive 3/8. Is it less than or equal to 0? Okay, so it is not because 3/8 is greater than 0. Therefore, the statement is false. So, we can say now that negative 5 is not a solution of the given inequality, or the numbers which are less than negative 2 are not solutions of the given inequality. Then we have the second interval. We use 2 as the number which is greater than negative 2 but less than 3. So we have to substitute 2 plus 2 over 2 minus 3 is it less than or equal to 0. 2 plus 2 is 4. 2 minus 3 is negative 1. 4 divided by negative 1 is negative 4. Is negative 4 less than 0? Okay, yes, it is less than 0. So therefore, it is a true statement. If it is a true statement, we can say now that 2 is a solution, or the numbers which are greater than negative 2 but less than 3 is or are solutions of the given inequality. Then we have the third interval, so we use 7. 7 plus 2 over 9 minus 3 is less than or equal to 0. 7 plus 2 is 9. 7 minus 3 is 4. 9/4 is less than or equal to 0. Then we simplify 9/4 as 2 and 1/4. So 2 and 1/4 is less than or equal to 0. So the given statement is false because 2 and 1/4 is greater than 0. So we can say now that 7 is not a solution, or the numbers which are greater than 3 are not solutions of the given inequality. So the solution set is given by the set of x such that x is a real number and x is greater than or equal to negative 2 but less than 3. The graph is shown below. So we have The solutions now of the given inequality are the numbers which are greater than or equal to -2 but less than 3. The domain of a rational function f of x is equal to p of x over qx is all the values of x that will not make q of x equal to 0, and the range of the function is the set of all values that f of x will take. Now let us have our topic, how to find the domain and range of a rational function. Let us have the following examples. Number 1. Find the domain of f of x is equal to 1 over x. The restricted x value of f is 0. Hence, the domain of f is the set of all the real numbers except 0. Thus, the range of f is the set of all real numbers except 0. Number 2. Find the domain and range of the rational function f of x is equal to 2x minus 3 over x squared. First, we equate the denominator x squared is equal to 0. Therefore, x is equal to 0 by extracting square root. So, the domain is the set of x such that x is an element of a real number where x should not be equal to 0. Or simply, it is the set of x where x is a real number such that x should not be equal to 0. That is, all values can take the variable x except 0, because when the denominator becomes 0, f of x will be undefined. To find the range, we use f of x is equal to y, so that y is equal to 2x minus 3 over x squared. Then we cross multiply. Y times x squared is yx squared or x squared y. And then 2x minus 3 times 1 is 2x minus 3. Then we have to transpose 2x and negative 3 at the left side. So we have yx squared or x squared y minus 2x plus 3 is equal to 0. So you can see that the highest degree of the given equation is 2. Therefore, it is quadratic equation. So, the given now is in standard form of a quadratic equation. So we have ax squared plus bx plus c is equal to 0. Now we use b squared minus 4ac is greater than or equal to 0 to get real solutions. So we let a as y, then our b as negative 2, and our c is 3. Therefore, we have to substitute. So, we have negative 2 close quantity squared minus 4 times y times 3 is greater than or equal to 0. Then, negative 2 times negative 2 is positive 4. Negative 4 times y times 3 is negative 12y is greater than or equal to 0. Then, next we have 4 is greater than or equal to 12 of y. Then to solve for y, we divide the two sides of the inequality by 12. So y now is less than or equal to 1/3. In summary, we have the domain or d of x is equal to the set of x where x is a real number such that x should not be equal to 0, and the range is the set of y where y is a real number such that y is less than or equal to 1/3. So we have our example number 3. Find the domain and range of the rational function f of x is equal to x minus 2 over x plus 2. First, we equate the denominator. So, if x plus 2 is equal to 0, therefore, x is equal to negative 2. The domain now is the set of x such that x is a real number and x should not be equal to negative 2, which means that is all values can take the variable x except -2 because the denominator becomes 0 and f of x will be undefined. The interval notation can also be written as the domain is the union of -infinity to -2 and -2 to positive infinity. So we used parentheses at -2 because -2 is not included. To find the range, we use f of x is equal to y, so that y is equal to x minus 2 over x plus 2. In solving this, you just multiply y and the denominator x plus 2 so that it becomes xy plus 2y is equal to x minus 2. Then next, we transpose x at the left and 2y at the right. So we have xy minus x is equal to -2y minus 2. Then we apply common factoring at the left side. So the common factor is x. Xy divided by x is y. Negative x divided by x is -1. Then we also apply common factoring at the right. And the common factor is -2. -2y divided by -2 is positive y. -2 divided by -2 is positive 1. To solve for x, in terms of y, we divide the two sides of the equation by y minus 1. So our x now is equal to -2 times the quantity of y plus 1 over y minus 1. Then we equate y minus 1 to 0. So y is equal to 1. Therefore, y is not equal to 1, otherwise the denominator is 0. The range now is the set of y such that y is a real number and y should not be equal to 1. That is, all values can take the variable y except 1 because the denominator becomes 0 and x will be undefined. We have our example number 4. Find the domain and range of f of x is equal to x over x minus 1. First, we equate the denominator to 0. So we have x minus 1 is equal to 0. Therefore, x is equal to 1. So the domain is the set of x such that x is a real number and x should not be equal to 1. That is, all values can take the variable x except 1 because the denominator becomes 0 and f of x will be undefined. To find the range, we use f of x is equal to y so that y is equal to x over x minus 1. In solving this, you just multiply y and the denominator x minus 1 so that it becomes y times the quantity of x minus 1 is equal to x. Then we apply distributive property. Y times x is xy. Y times -1 is negative y is equal to x. Then we transpose x at the left and we transpose -y at the right. So we have now xy minus x is equal to y. Then we apply common factoring at the left side. The common factor is x. Xy divided by x is y. Negative x divided by x is -1 is equal to y. Then, to solve for x, we divide the two sides of the equation by y minus 1. So, we have now x is equal to y over y minus 1. We equate y minus 1 is equal to 0, y is equal to 1. Therefore, y is not equal to 1, otherwise the denominator is 0. Next, the last one is find the domain of the rational function f of x is equal to 3x squared minus 8x minus 3 over 2x squared plus 7x minus 4. First, we equate the denominator 2x squared plus 7x minus 4 to 0. So by factoring, we have the quantity of 2x minus 1 times the quantity of x plus 4 is equal to 0. Therefore, x is equal to 1/2 and x is equal to negative 4. So the domain is the set of x such that x is a real number and x should not be equal to negative 4 and 1/2. That is, all values can take the variable x except negative 4 and 1/2 because the denominator becomes 0 and f of x will be undefined. The interval notation can also be written as the domain is equal to the union of negative infinity to negative 4, negative 4 to 1/2, and 1/2 to positive infinity. And we use parentheses at negative 4 and 1/2 because they are not included. Now let us see if you remember our lesson. The distance between the school and your home is 20 kilometers. Express velocity v as a function of travel time t in hours. Who will volunteer? Okay. The correct answer is function v of t is equal to 20 over t can represent v as a function of t. Next, determine whether the given is a rational function, a rational equation, or a rational inequality. Number 1, 1 plus x over x plus 2 is equal to 4. Number 2, 5x is greater than or equal to 2 over 2x minus 3. Number 3, f of x is equal to 7x plus 5 over 3 plus 4. Number 4, x minus 5 over x plus 2 is equal to y plus 3. Hint, y is represented by f of x. Number 5, x plus 2 over 8 is equal to 3x over 2. So, who will answer letter B? Very good. The correct answers are number 1, rational equation, number 2, rational inequality, number 3, rational function, number 4, rational function, and number 5, rational equation. Next, letter C. Fill in the blanks. To determine the domain and range in rational functions, blank the denominator to blank and solve for the variable x. The objective is that it must have blank denominator. The value that would make it 0 is the value that would not be included in the domain. To find the range, solve the equation for x in terms of blank. Again, it must have non-zero denominator. The value that would make the blank equal to 0 is the value that would not be included in the range. Again, who will give his or her answers? Excellent! The correct answers are number 1, equate, number 2, 0, number 3, non-zero, number 4, y, and then number 5, denominator.
That is for today. I am glad that we finished 4 learning competencies from our lesson. Continue doing the activities in your worksheet, and I will give you an activity and do this as your performance task. Your performance will be rated using the given rubrics. So this is the activity. You are analyzing your bills in Abreco for the consecutive months. Using your bill at home, express the amount per kilowatt hour represented by A as a function of kilowatt per hour represented by K, consumed for the last 2 consecutive months. Then create austerity plan for the next month. Austerity means measures taken to reduce spending.
So this is the austerity plan. Your bill for the last 2 consecutive months. Then create a rational inequality showing the relationships between the bill in the last consecutive months. And then list down the austerity measures to be undertaken to reduce the electricity consumption. Then this will be the rubrics to be followed. This will be the categories: solution process, planning, accuracy of solution. For solution process, you will be given 3 points for complete and appropriate solution process, 2 points for an appropriate solution process that is partially complete, and then 1 point or poor performance if you are needed extensive guidance to work on the problem. Then for planning, the goal set is achievable and realistic, 3 points. For 2 points, the goal set is hard to achieve. 1 point, the goal set is not achievable and not realistic. Then we have the accuracy of solution, 3 points for the computation in obtaining the desired profit using the profit function is correct. 2 points if the computation in obtaining the desired profit using the profit function has flaws. Then 1 point if there is no attempt in computing the desired profit using the profit function.
I hope you learned a lot from our discussion. Once again, this is Teacher Eleanor. I will end my topic with this simple message to remember. Study hard and focus on your goals. One day, you will make yourself proud.